You did it. Achievement unlock. You've made it to the JavaScript Masterclass. We'll be covering Playwright up through version 113, which is current. I plan to add feature updates in a playlist on my page, but this video will be focusing on JavaScript. You can use other programming languages like Java, C#, or Python, and most of what I cover in this class will all be relevant to those, as well as other testing frameworks that exist. But what will we be covering today? What is it? What is it not? The Playwright Test Runner, getting started, test generation, tracing, recording, authentication, and you better channel your inner Billy Mays here but wait, there's more. There's all kinds of tips, tricks, and settings that you're going to want to use when you're running Playwright. First, what Playwright is. Playwright is a browser automation framework. That doesn't mean anything about unit tests. That doesn't mean anything about UI tests. It's for browser automation. So it has APIs that allow you to do anything you want with the browser. That means that you can interact with the browser like Firefox, Chrome, or WebKit. You can do things like download, you can click and drag, you can check the network tab, you can check the console. Anything that exists in those dev tools, you basically have access with Playwright. But what about all these other tools that exist? What about Cypress, Unified Functional Testing, Selenium, Test Cafe? What's the difference between Playwright and those tools? Well, Selenium is a web driver, which means you can only control the browser as you could from your mouse and keyboard, which means you don't get to see the internals of what's going on with the browser. You can sometimes load other JavaScript and customize it so that you can do those things, but out of the box, you don't get that. You also need to get support from multiple different places. When you want IE support, you need to go to Microsoft. When you need Chrome support, you need to go to Google. When you need Firefox support, you need to go to Mozilla. So when Selenium's updated, the drivers aren't instantly updated for you. Those happen later behind the scenes, and someone's supporting that isn't on that main development team. Cypress and Test Cafe are a little bit different because they actually run Node.js as a kind of middleware on your page, where they kind of inject their script inside of your page when they run, which gives them a little bit more access to the browser than Selenium does, but still doesn't give you full access to the browser. And depending on security models and other things going on, that may or may not work for your page. Specifically with Test Cafe, I've seen issues with authentication, and I've just not run into those issues with Cypress or Playwright. I believe Cypress, unless I'm wrong, only still works for Chrome. That's not a problem with Playwright because Playwright supports all modern browsers. UFT is a little bit different. It's trying to automate a lot of things, not just browsers, but desktop apps. It's okay if you want to pay the licensing fee, but all the rest of the tools on the screen are free. So it has to be that much better in my book to edge out these other tools. So I don't want to say that UFT is bad depending on what your use case is. If you have to test a full desktop app, UFT might be okay. But for testing browser apps, it leaves a lot to be desired. So what do we have here? This is actually a view of how Playwright works behind the scenes, because you can see at the bottom that there's an Apple, a Windows logo, and a Linux logo, because those are the operating systems that Playwright works on. So the tooling's the same for all operating systems, and it runs on the Chrome, WebKit, and Firefox browsers. But when they update, they're actually updating all three operating systems with all three browsers at the same time. So when you get to release 1.13, like is released today, that was updated for all operating systems and all browsers. That's also, if you look up above, updated for JavaScript, C#, Java, and Python. So all of them get first-class support. You don't have to wait for C# to update its API 3 releases after the JavaScript one, because the JavaScript's the main one. You don't have to wait for Java to be updated. When everything's updated, it all gets updated together. It's all supported together. It does give Playwright a funky release cycle, because I believe they've got a 35-day release cycle, but that's still blazing quick for a lot of these tools. The new features that come out every month or so are pretty great when they do come out. Just as a reminder, Playwright is not a test framework. It's not a BDD tool, it's not for general testing, and it's not testing desktop apps. It's for programmatically manipulating a browser. So what's Playwright Test? Playwright Test is a Node.js testing framework meant for Playwright that gives you a lot of advantages that the other testing frameworks don't have, and it was new to version 1.12, so it's pretty much only about a month old at this point. It's a test runner specifically designed for Playwright and the other capabilities it has. Jest or other JavaScript runners leave a lot of configuration up to you, and some of the advanced features don't exist in Jest, or they're very difficult to do. And it's got special features that we're going to look at. Looking at the API really quick for Playwright Test, you can see it's really easy to install. And once you install it through NPM, you can install the browsers with this easy command line. And then there's a pretty simple syntax for writing your first test. We'll get to all of this in a second, but there's also these test fixtures that exist that make it really easy to access things like your page or the browser. You can just pass those into your test, and we'll get deeper into this as well. Most of the time, Playwright will use the latest version of a browser or even ahead of the last one released. They do this for a specific reason, so that you can always make sure that your code works with the next browser that's coming out, because they're assuming that it has backwards compatibility with everything that already exists. So this is definitely better than like Selenium, where it follows a release anyway. So you always have the latest browser features. You know it's going to work on the next releases before they come out, because if it breaks with some new feature Google's adding, you want to know that before it releases rather than after it releases, because you don't want your site broken and have no idea why it broke. So what do you need for system requirements for Playwright to work on your system? Today we're using Windows. I'm not going to use the Windows subsystem for Linux, but it would work. The only real requirements are Node.js version 12 or above, and then for you to actually install the binaries. If you're using Linux, only Ubuntu is officially supported, and only those specific versions that I have highlighted on the screen. This is our installation steps for NPM. We're basically going to run npm i-d at playwright/test. I will do that with a time lapse, so you don't have to sit and watch that progress bar go across. And then we're going to run npx playwright install. So when you install this Playwright Test package, it installs everything you need except for the browsers. So when you run that Playwright install, it will actually install those browsers at the latest version. So jumping into Visual Studio Code, you can use whatever text editor you would like. It does not matter at all to Playwright. They're just JavaScript files that we're going to be creating. Use whatever tool you're comfortable with. I'm going to use Visual Studio Code, and it should work pretty good for our demo here. The first thing I'm going to do is open a terminal. And in this terminal, we're going to do the commands that we just saw. We're going to do the npm i-d at playwright/test. And once that finishes, we're going to do the npx playwright install. With that out of the way, what we first need to do is create a folder here, and we're going to call that tests. With that folder created, we're going to create a file in there. When you name this file, you can name this file whatever you'd like it to be, but it has to end specifically in spec.js. That way, first, your text editor knows it's a JavaScript file, but spec.js is what the test runner is going to look for your test files. With that out of the way, I'm going to go ahead and paste in the default example. You can check the links in the description if you want to copy this snippet, but the most important part here is that at the top we've included test and expect from the Playwright Test library. We have test thing here that will allow us to run a test. We have a name of the test, and then we have our fixtures here that we're passing in page. We're not going to talk about where that comes from, but that is provided to us by Playwright Test. And then that page actually will go to Playwright Dev. It'll grab the inner text off the class navbar underscore title. We'll talk about selectors in a little bit. And then it'll compare whatever value it gets back to make sure that it is equal to Playwright. So let's save that and run this here. But how do you run it? The way that you can run these is with the command line using npx playwright test. And when you run that, it'll start up a test runner using one worker, and you can see that it's going to use the Chromium browser. It gave us a green check mark. It gives us the file path, the line numbers, and the name of the test, and said it took 4 seconds to complete. If we rerun it, you'll see that the first time took longer than normal. The first time you run one of these tests with the browsers, it takes long for them to spin up. Once you run them, they go much faster. So we got through that first run, but you can see the default is that Playwright will only use Chromium, which kind of makes sense. What if you want to use a different browser? So one thing you can do is you can actually define which browser you want your test to run off of. This is the cool thing about Playwright Test, or one of the cool things about Playwright Test, is that you can define the browsers at runtime, and then you don't have to go change your code to modify all the browsers. And kind of one of the things you have to do with Selenium is switch the browsers in your default settings, Well, here you don't have to do any of that. If I go ahead and just hit enter, what it'll do is it'll show you that now it's running Firefox. But it's not too obvious that's actually running in Firefox. It's running headlessly. So you can actually fix that by also passing another command here, and that's headed. So if we include headed when we do that run, we'll now pop up the browser. So you can see it's a Firefox browser now running that test. Firefox happens to run slow when it's headed. If we just delete that and run the same thing in Chrome, it runs quite a bit faster. We can do it again just to see if it runs any faster the second time. So it is a bit faster, but it's still kind of slow. But what if we want to use all browsers? If we want to use all browsers, we can switch from Firefox to all, and we can get all 3 browsers at once. So you can see it's kicking off Chrome, Firefox, and WebKit, all running headed, which is pretty cool. And you can do the same thing without headed, to just run them headlessly in all browsers. So let's add another test. So here you can see that I added a test. Oops, because this one's gonna struggle for a little bit. But what I'm gonna do here is I'm gonna show you the website we're gonna hit first, and we're gonna use this UI test automation playground. It's a free resource that's out there that you can use to test automation frameworks. It's really nice. It has a lot of advanced features. But you can see down here, we're gonna hit this one called scroll bars. So we're gonna go to this link here, and then there's a button hidden here that normally you would have to scroll to and then click on. We're going to do that in a test here, and if you can't tell by the test name, it's going to fail the first time, but we're going to work through that too. So the way we wrote the test was we're going to go to that scroll bar page, and then we're going to click on hiding button, which I've intentionally spelled wrong, but we're going to go to that ID and see what happens. So if we just run in one browser, since we know this is going to fail, through the magic of editing, you can see that that test took 31 seconds. So it failed, and a whole bunch of stuff got kicked out of the logs. If you look here, you can see that it was waiting for selector hiding button, but it failed when it tried to click on it, and it timed out and it kicked out the test. So this is fine when we know what the problem is, but how would you figure that out if you needed to debug it? And luckily, there's a lot of different ways that you can figure this out. First, let's talk about what's going on in the test, because you'll see that we're not doing something that happens in a lot of other test frameworks. We're not actually waiting for anything. It'll automatically wait. It waits for the browser to settle down. It waits for elements to exist. It knows when that page is loaded because it is the browser, so it can make sure all those requests have finished. It would also look and scroll to that item. So if it wasn't on the page, it's going to locate it and move the page over to it for you. So we'll see that in a little bit, but let's take care of debugging this test here. So one of the ways that you can debug is you can set an environment variable pwdebug equal to 1. Since I'm using PowerShell here, it looks like this. It's slightly different for other languages. In their documentation, they can show you how to do it for Linux and Mac OS. And now you would just run your tests the same way you would normally run your tests. But now something different is going to happen, because they have a command line tool called this Playwright Inspector that allows you to step through your tests. And you'll see that it actually steps into this Playwright code, goes and does things, and will let you kind of see what the test is doing while it's running. So here we have our test, this Playwright UI playground, and when we get to our second step, you can see that it's got to this page. We can click these buttons, and it says it's waiting for this selector hiding button. That's where it's going to fail. You can see all the steps that it was doing up until that point. So it's kind of cool, but I don't think it's super helpful knowing what's going on, although you can navigate around the page here and click on this explore button, click on this, and it'll give you a selector that works for that button. You can also do that, and it'll show you where that button exists, because it shows you right there that hiding button is actually this button. And if we misspell this button again, it won't know what to look for on the page. If we remove that D, it goes and it highlights it for us. So that's pretty cool. That gives us a way to debug our page without having to kind of guess what's going on. But maybe we can do a little bit better. So I'm just going to close this, and then let's go ahead and use one of those fancy annotations and do only here. So that way we're only testing this one. And we wanted to change this debug to be console instead of 1. Do not ask me why they chose 1 and console as values. So now we're just going to run our Playwright test again and see what happens. So now it's only running that one test. It ran it headed, which is kind of cool, without us passing that headed parameter. If you hit F12 here, if you go to the console, you can type Playwright, and then you can see this $, which allows us to use a selector. And then if you use something like a CSS selector here, so now we're going to use the Playwright $ hiding button. And when you do that, it can actually locate the button. And if you hover over it, it shows you it's kind of in this hidden area on the screen. And we can do that again to evaluate anything else that might be on the screen. And you can see that the one that we're actually looking for is undefined, so it can't find it. But we can also do other selectors, XPath, CSS, or this special text selector, and see what these find. So these are pretty cool because they allow you to see what Playwright's seeing while you run your test. But maybe that's not helpful enough for our test, so we can even debug a different way. So the first thing I'm going to do is turn off this PW debug. And the way you do that in PowerShell is you set this to like an empty. When we check that empty value now to prove that it's off, we see that we get nothing back when we check that value, which is exactly what we want because now we have to switch another one. If we really want to see diagnostic traces at the command line of what's going on in these tests, we can set the environment variable of debug equal to pw::API. So when we do that, let's run our npx playwright test again. And this time our console just gets flooded with a whole lot of other information. But we can see that the browser launch started, it succeeded, the new context was created, a new page was created, and you can tell all we have is a page here, so it's doing all that stuff behind the scenes in its fixtures. It navigated to where we told it to go on line 10, and then the DOM content loaded, it succeeded, the click started, sorry it scrolled on me. So when we got to the page click started, you can see it's waiting for the selector hiding button. A network event idle fired, the browser context closed, the click failed, and then everything else closed behind it. And then you can see here it timed out with 30 seconds. So that's really cool, and especially if you were doing these on a CI server, you could pipe that console output to a file to debug or push to other testing tools, so you know exactly what's going on your CI runs. So that's really cool too. But there's probably another way that we can do this that might make it more obvious, especially if you have a longer test. Sometimes it's just cool to use a UI tool. So let's take a look at how you do that here. First things first is I'm going to remove this variable from debug. So we can see our debug's no longer set, so that we're not going to get that console spam. I'm going to go ahead and modify this test really quickly. And you can see here what I've done is I've added a new fixture of context. And what we can do once we have that context is we can turn on tracing. So here it's going to turn on tracing with screenshots and snapshots. It's still going to go to our page. I went ahead and fixed the hiding button to be spelled correctly. We're going to basically stop the tracing and tell it where that trace should go. This is still the only test that's going to be run, so let's go ahead and run our tests. And when you do that, you can see here I made a mistake when I updated my tests. We removed the full URL of scroll bars. I'm just going to put that back here and rerun our test. So now we got the test passing, but we also have this new thing that got added to our files, which is trace.zip. So what do you do with that? Well, we're going to use a command line tool that shows the trace. So the command line tool we're going to use is npx playwright show trace, and then the name of the trace file, which in this case is trace.zip. So if we run that, we get this tool that I'm in the full screen here, we get this scroll bar, or this bar across the top that shows the page state, which nothing really happens because this one runs so fast. But around 240 milliseconds, the page will start loading in, and you can see here it goes from unloaded to that page is actually loaded. And then it moves on to the next step, which they've color coded here. So blue's the first step and green's the second step. And then you can see that as this goes through, you can see that even some other icons keep popping in while this click event happens. But if we go over here to actions and we click on actions, we get this other menu bar. And you can see that the action doesn't really do anything on GoTo, but there's a before and an after, there's calls, there's this console logs, there's network, which actually shows us everything that's coming in on the page on that network call. And then source, which shows us what our source is for our unit test. So that shows us the line number of the trace that we're going through, which is kind of helpful, especially with longer tests or tests that call into other items. Having all these actions stacked up, being able to click in when you're 30 steps into a test is probably pretty useful, especially if you're using something like page objects, which call off into other areas. This can be super helpful when debugging a test. So if we go back over here to page click hiding button, what you can see is that the action shows that there's a red dot, that somehow this is where it clicked on to click on this hiding button. But you can see that it also managed to scroll in and down to find that button, which is that really cool part of Playwright where it'll do those things for you. And you can also see here that before it wasn't in view and after it is in view. So that's a real cool thing you can see. But you can also see on the side that you get these other API traces that we saw when we used that debugging. You can see that the logging shows that it's waiting for hiding button, it resolved as visible, it attempts to click, and it wasn't able to do it, so it actually scrolled it into view. Once it finished scrolling, it performed that click action, and then it kind of waited for navigation to finish afterwards, and then it finished up the test. And again, nothing happened in the console, nothing happened in the network, and the source is just showing that button again. So that's a really cool tool that you can use. The way I've seen it, you can basically only write one trace at a time because it's using that static file name. You probably don't want to create a zip for everything every time they run, but when you're creating a test or trying to figure out why a test is broken, this is definitely a cool tool to be using that can save you some time. So before I added this test oops, which we're going to update here. So now we've got our test hiding scroll bar. I'm going to go ahead and remove this tracing. We'll just leave this fixture here for now. It doesn't really matter. But I just don't want it creating this file every single time. It kind of just slows it down. But we want to update this because if we assume that the page we were testing every time wasn't Playwright Dev, it was actually the UI testing playground, we wouldn't want to include that all the time in our page, right? We would only want to include that once in one place, and that way if we wanted to hit a website in dev, production, or anywhere else, we could just update that URL from maybe localhost to a specific URL, and we wouldn't have to go modify all of our tests. So it'd be really cool if we could just remove this and run our test this way, which right now this is going to fail because it doesn't know what that base URL is, but let's go ahead and add that. So the first thing we got to do is create a new file, and let's hope that it's going into the right folder, which it's not, but I'll move it. So the file we are going to create is playwrightconfig.js, and I'm going to move this down a folder. So now that it's in the correct folder, we need to add something here. And this was basically stolen from the Playwright API docs. I don't know why we need lines 1 and 3, but they're there. The only real important line is that we have a config, we're exporting it, and we have a base URL set. So now with this base URL set, and our test spec just giving this relative path, let's go ahead and run our tests. And now it works. Just changing one file, the base path, in that Playwright config JSON. So if we want to redirect these to any other page, we can just change it here. If we were running this locally, for instance, we could say localhost port here and here a local one rather than the one on the web. So that's a really cool feature that can save you a lot of time, effort, and it's just a best practice when configuring your tests. The next thing I want to talk about is authentication. It's cool that you can hit an unauthenticated page, but that's not super helpful to most of us because usually you have to log in to see some parts of the page. So what do? Do you just log in every time before a page? Because that's kind of slow, and who really wants to do that? If we go out here to this link on the Playwright documentation, they show us how to automate logging in. They have us create a new page, go to a page, click a text link, submit a username and password, and then submit. We can also then reuse this authentication state by saving it and then recalling it from another page. So let's go create this. So again, we're going to create a global spec file or a global config file. Let me remove this trace just so we don't see it anymore. And the file that we want to create here is going to be called global-setup.js. The naming's probably not super necessary. We're going to hook it up in our Playwright config in just a second. But what's inside of this is far more important. So basically stealing what they had in that example, we're going to do the same thing. We're going to require Playwright Test. We're going to launch a Chromium browser. We're going to create a new page. We're going to go into Netflix instead. We're going to look for a text sign-in, which is on the Netflix page. We're going to look for an input with the name of user login ID. We're going to pass a user value that I'm not going to show you. We're going to pass a password that I'm not going to show you. Then we're going to click the login button. Once that's done, we're going to take that page context, storage state, and save it to a path called netflix.json, which is going to basically store the cookies and all this other browser state for us. And then we're going to go ahead and close the browser. But the cool thing is that this will run one time when we update our config here. So what we want to do in our config, not inside of this use, but next to it, we added this value of global setup where we require it to resolve global setup. We don't have to include JS, but you could. But what's really important is that that's just a relative path, and you can put that anywhere you like and call it whatever you'd want. So I'm going to go ahead, update my username and password, get this ready to run. And again, through the magic of editing, I've went ahead and updated it in the global setup to put that private username and password in there. I'm going to get rid of that only and then create a new test here. And this test is going to look similar, but now we've added this test.use and we've said use the storage state of netflix.json so that this next test will basically use that. We could also put that in that Playwright config.js, but if you wanted to change it to different users because you've stored different states, that would work. Right now, netflix.json doesn't exist because the global hasn't ran yet the first time. But you can see here that basically when I run this, I'm only going to run this Netflix auth test because I removed the only up here. We're going to go to netflix.com/browse. If you do that right now, if I open a new incognito browser and paste in this URL of Netflix browse, let's see where the page goes. By default, it says I'm not logged in. So if the authentication is not working, it should show up to this email sign-in screen. But instead what I'm going to do is I'm going to check for an element and see if who's watching comes up. So let's see what happens when we run this. Let me save first to make sure that it works. So just running our npx playwright test. Now that we've hooked up the Playwright config to the global setup's going to go ahead and run and generate that netflix.json file. So that popped up here. And then you can see our test passed because something happened there. You couldn't really see what happened there, so let's go ahead and run that in the headed mode so you can see what happened. And you can see it popped up to a who's watching screen instead, so our authentication worked. Now, we don't need to run that global setup every time. So what you could actually do is you could actually just comment this out here, save it, and then you can just keep that one file locally rather than running the global setup every time. Still logging in one time versus 100 times is an improvement. But if you had different JSON files of your authentication saved, you could keep those checked in as like test users, go to different tests using those different users without having to log in or at all during your tests. So if we go back to our first test spec, now that we've removed that item, it's just going to use this stored file that we have created. And running it again here, you'll see it still works. It just works faster because it didn't have to log in first. I know I moved through that fast. I'll have a link in the description for authentication, but it's really cool when you can get that working. We're building up quite a few tests here. So one of the neat things that I want to show you about Playwright Test is kind of how these BDD tools work, where you can do descriptions and tests, and you can kind of build out a sentence of what your test is going to look like. So right here, when my test runs, you can see that it just says Netflix auth, because that's the name of the test. What you can actually do is with describe, you can wrap multiple tests. So it kind of creates this group of tests here. And it doesn't do anything too special, except for it can make it easier to see what's going on. So here we've added the text of dynamic scenario. We have test names of goes to page and does the same. So these just go to a special page that we've already got on our base URL. Let me remove this only here. And with only removed, we're just going to go ahead and run all the tests that we have here. And when you look at the command line, you can see that it says basic test, test hiding scroll bar, Netflix auth, and then you can see dynamic scenario, goes to page, does the same. And maybe how you're grouping your tests, you want it to do like the page name. So we added the page name there, but maybe we have a test scenario that we want to run these on. And you can obviously group these a lot of ways, but I just want to show you when you nest this describe in here. If you include the proper items to close that. When you have two describes here, you can say nested description. So what you can actually do is kind of build out a sentence saying something like, on page name, doing this thing, whatever the expectation is. So if I go ahead and run this again, what you'll see is it almost builds out sentences for you, where you have page name, dynamic scenario, nested description, goes to page, or does the same. So it doesn't really matter what you do, but this is just a way to organize your tests, or to make it more descriptive of what your test is actually doing. And if they are grouped, that also makes it easier to go find them in your source control as well. Besides having the line numbers and specs, sometimes on your test output, it's a lot easier to tell what's going on and search for this or a part of this so that you know what you're looking for. So we've built out a lot of tests, and hopefully you've stuck with me through all this because we went through a lot already. What if you have a page you want to go to, you don't really know the API, but you just want to click through some stuff and generate a test? What if you want to do something like that? Well, let's get into some dynamic generation. So what you can do is there's a command line tool, again, that we're going to use called Playwright. And if you look at the help, there's other commands that we haven't messed with so far. But what we're going to do is this Codegen here. So with Codegen, what it does is it opens up a new tool that has this inspector that we used before when we were debugging. But what you can actually do on the page now is you can navigate and use this page like any other page. So let's say you wanted to go to this dynamic ID and you wanted to click this button, and maybe you wanted to go back to the home page. I clicked an extra mouse button. Let's go to non-breaking space. Then let's click on this My button and take a look at what's happened here. So I know it might be a little bit small. I'll try to enlarge it here. But you can see that it's basically built out a test for us. It's got a require up here. It's got a test that we could copy and paste. Mine's still recording, so I'll stop it here. There's that Explorer that we saw before that lets us hover and see things. And then there's this copy button that lets us copy this over, pull it back over to our test, and just paste everything in there. But the real cool thing here is, like I said before, Playwright isn't just a JavaScript tool. It's a Python tool, it's a C# tool, it's a Java tool. What you can do here is you can change your target after the test has been ran to go ahead and switch this over to Java, switch it over to JavaScript. You can go to Python, you can go to asynchronous Python, and you can go to C#. And really, it doesn't matter which language you go to. The syntax is almost identical. So even if we go to this Python one here, even if you don't understand Python, you can pretty much tell the same things that we've been saying. You have context new page, you have go-tos, you have clicks. But this allows you to go through all of this without having to necessarily learn that language. You could start learning that API this way. But this has also added some other things in there. So when you did the page click, we expect the URL to go to a certain page. which, maybe that's a good thing to do in your tests. Maybe it's not. You can delete it. This is just generating a sample of what you would do on that test. Every time that it goes to a URL, it expects that page to change. And then it also has some other examples of other selectors that you could use. So the selectors I like to work with the most are probably the CSS selectors. And this is the W3 schools. Links are down in the description. But you can see that you can get classes with a period in the class name. You can get IDs by the hash and the ID. You can use stars to select all elements. You can do chains and fuzzy things. And this cheat sheet's a little bit nicer, especially if you're learning these. It's a little bit more helpful telling you what the things are. It's a little bit easier to read. And you can see that you can add these and kind of do some precedence settings. All of these are supported in Playwright when you do a selector. So when you're clicking or anything else, you could use this or you could use these. As long as it's supported by the browser, Playwright knows what it is. The other kind of selector you can use is an XPath selector, which is really an XML document selector, which an HTML document is basically an XML. So if you can imagine this is what your HTML looks like, you can use / to select from the nodes. I'll let you guys read deeper into this if you want to. Check out the links. But the cooler thing is this XPath cheat sheet. That W3 Schools is great, but sometimes you just want some specific idea of how to do things. And what this will actually do is map the CSS selector to an XPath selector. So you can use these. Chrome has some cool tools that allow you to find what's on the page using XPath selectors and CSS selectors. You can dig deeper into selectors. But I just wanted to give you these resources so that you could see really how you can access elements on your page and see what elements are on your page. So I know we went really long on this, but you can see that there's a lot of opportunity to build tests, to manage tests, and to really go deep in what you can do with the browser automation. There's one more thing I want to show you, and that's these experimental features. Playwright is at version 1.13 as of today, but they're not done building out all the features. So Playwright has some experimental support for Android automation, so you can actually do this, and I believe it's Java, maybe it's not doing Java, but it can connect to an Android device and start running your tests. They have this bigger API here, which I don't know what any of that means yet. They allow inputting with swipes, taps, and drags, sockets, web views, and then they have Electron here. That's also an experimental feature. So I'm not sure if they're going to add iOS in the future. I'm not sure if they're going to make Android a full supported operating system. But they've got some cool things coming, and Electron's another cool experiment that they have where they show that you can evaluate things inside of your Electron app. So I just want you to know that they are not done building features, and they keep bringing out a lot of cool features. In their API and their docs, you can actually go here and see their next, and you can see kind of what they're building. If you go into their release notes, you can see that they put out a lot of cool features, and you can constantly see what's getting updated here. We're to the end of the video, but if you want more Playwright, check out my Python Playwright playlist. I'll have a link up here. Like and subscribe if you made it this far. I mean, you made it this far, right? I earned it, I think. I think I earned it.